Hi there. As we begin this chapter on rational expressions, you're going to find that we do a lot of operations with these rational expressions, and rational expressions are always fractions, so I always want to kind of start by looking back at just a regular fraction and remembering those rules, and then we'll do the same thing with some variables. So looking at this, if you try to take 2/12 times 3/7, okay, the first thing you always want to do when you're multiplying fractions is try to reduce. And you can reduce anything as long as you have something on the top with something on the bottom. So like I could reduce this 2 and this 12. That would reduce to a 1 and a 6. But I can also do this kind of at a diagonal. I can reduce a 3 and a 6 also, so that'd be a 1 and a 2. Once you've gotten all the reducing done that you can, you just multiply straight across. So 1 times 1 gets us a 1. And then 2 times the 7 gets us 14. So now we're going to do the same thing with a bunch of variables in there. So looking at this example, notice there's no pluses or minuses. These are all just single terms. So we're looking at numbers first of all. And I could reduce this 4 and 16 if I divide them both by 4. I can also reduce the 5 and 15. They both divide by 5. So there's that part. But you also have these variables. And so if you look at this and you look at how many of each type of variable you have on the top or the bottom, so in this case, I'm going to write this out. You don't necessarily have to always write it out as in this many steps, but what's really going on here is on the top, number-wise, I'm going to have a 3, and then I have an x squared. That's an x times another x. So it's really an x times x times x. Now, futuristically, you're not going to write this out that many times. I'm just showing you what's happening. And I have a y cubed, so that's a y times a y times a y. On the bottom, numbers, I'm going to have a 4, and I have an x, and I have a y, and then I have a y squared. So here's what's going on. When you try to reduce, in the same way you can reduce numbers, you can reduce variables. This x could divide out with that x. This y could divide out with that y, and this one, and this one. And so what you're looking at then is, after you divide those all out, what's left. So your final answer on this would be a 3, and we have 2 x's on top, so we'll call that x squared over a 4. And that's our final answer. Now, let's try to do that without having to write this whole thing out. Not that you can't, you still can, but if you just look at it and you say, I've got an x squared and an x, or maybe I could just reduce this x with this x, and then all I'd have left is this x squared on top. So that would be one way to get that. If you look at your y's, you could look at this as like a y cubed and a y squared, and so you know that 2 of these would cancel out and you'd only have 1 left on top. So another way to think through that maybe would be to say, oh, that will cross off and just become a y because it crossed off with 2 of those. But then this y could cancel with that y, and that's why all the y's ended up canceling out on my answer. Okay, so do whichever way works best for you. What if you have some addition and subtraction going on these problems? All right, here's the rule with this. As soon as you have some addition, like right here, I cannot split these two things up because I'm taking n and I'm dividing by this entire quantity. So anytime I see addition or subtraction, I immediately stick some parentheses around that to group it together to remind me that I can't piece it apart. Dividing, like in these fractions, division can be undone with multiplication. So if there are things being multiplied, it's okay to reduce them, but not if they're being added or subtracted. So over here, I'm going to put parentheses around that because there's addition. I'm going to put parentheses around that because there is addition, and that groups it. Now, if there was something being multiplied, then it's fair game to try to reduce. So actually, what I'm going to do is look at these two right here and say, well, those look like something that could actually factor. So we're going to do a lot of factoring with these rationals. So the first thing I'm going to do is look at this trinomial, and I'm going to split it up and factor it to an m. Factors of 18 are going to be 6 and 3. They're both pluses. In the denominator, it looks like on this one that I could pull out a GCF. I could pull out an n. and then I'd have an m plus 3 left. On the right side, there's no factoring that can be done, so I'm just going to rewrite it. Okay, so here's what's nice about this. By factoring, I've suddenly created multiplication. Right there, those two things are being multiplied. Right here, these are being multiplied. As soon as I multiply them, now I have the ability to be able to reduce. So on the top, since I'm multiplying right here, this quantity could be separated from this quantity. And so what I'm looking to do is to be able to reduce the quantities, which I can certainly do. Right here I have an m plus 3. I have an identical m plus 3 in the bottom. I'm going to divide those out. Remember, when you cross things out, you leave 1 in their place. Okay, I have this n right here that can reduce with this n, so I'll cross those off. Oh my goodness, I also have an m plus 6 that can divide with this m plus 6. I got every single thing to cross off. Now, that's not common. Usually there's something left, but in this case, every quantity crossed off, and what I have left is 1 over 1, or just 1. And that's my final answer. That worked out beautifully. Let's try one more. Probably not going to work out quite as beautifully, but notice on this one that this is division. I had a heck of a time getting my division sign in there. It wouldn't let me do it, so that's kind of a ugly division, but that's what we're doing. We're going to divide these. Okay, so here's the process. We do not divide by fractions. Remember that you change this to multiplying by the reciprocal. So I'm going to change this to multiplication, and I'm going to flip this. Okay. I also see over here something that looks like it could be factored. So I'm going to do kind of both of those in one step. So let's start with this numerator. Looks like we can pull out a v. Then I'll have a w plus 8 left. In the denominator, it's a trinomial that's going to factor. I'm going to have a w, factors of 24. That'll add up to 11. I think that's going to be 8 and 3. Signs are the same. They're both going to be pluses. And now I'm going to change this to a multiplication problem. Anytime you see division, you'll change it to multiplication and then flip that second fraction. Okay, now we're going to look to reduce stuff. W plus 3's cross off, W plus 8's cross off, V's cross off. Okay, I lied. Apparently, I just pulled these off the software, so apparently they like to have everything cross off. So, again, it doesn't have to happen that way. Remember, when you cross things off, you're really supposed to be leaving 1 in their place, so I end up with 1 over 1 again, which is a 1. Okay, so there you go. Good luck.